world's largest source of recycled steel doesn't come from mines. Can you guess where it begins? From the auto recycling industry, often called the car's second gateway, which delivers a massive stream of steel to the global market every year. In the United States alone, more than 12 million vehicles are dismantled and recycled annually, turning scrap yards into some of the most efficient steel mines humanity has ever created. Each car, once thought to have reached the end of its life, embarks on a new journey. In this video, we'll witness how old cars are transformed into the raw foundation for construction, industry, and even the next generation of automobiles. You buy a car for $48,000. After 10 years on the road, how much value can it still hold once it enters the recycling process? Behind that question lies a $60 billion industry each year, where millions of old vehicles are dismantled, crushed, and reborn as new raw materials. This process provides jobs for hundreds of thousands of workers, cuts enormous costs for metal smelting, and greatly reduces the burden on the environment. And if iron ore is a natural mine, then end-of-life cars are an artificial mine without limits. Each recycling cycle saves up to 74% of the energy compared to mining new ore. On average, 75% of a vehicle's weight can be recovered, from steel and aluminum to glass and plastics. As a result, hundreds of millions of tons of material are reborn every year, continuing their journey as buildings, everyday products, and even the next generation of cars. When a car reaches the end of its life, it is delivered to the intake area of a recycling plant. Here, technicians record the vehicle identification number, engine number, year of manufacture, overall condition, and all related paperwork. They also photograph the car, attach a tracking code, and upload the full dataset into a digital management system. This step not only allows the entire process to be tracked, but also provides the basis for assessing the remaining value of each vehicle. The inspection focuses on components that can be reused, such as engines, transmissions, electronics, and interior parts. Usable components are separated and supplied to the multi-billion-dollar market for used auto parts. Fully worn out, on the other hand, are directed straight into the dismantling process for material recovery. Once this stage is complete, the cars are organized in lots across the yard, lined up and ready to enter the processing line in a clear, systematic order. What few people realize is that in the United States, more than 95% of end-of-life vehicles go through this system, making automobiles the most recycled consumer product in the world. Thanks to this level of organization, every car is able to maximize its recoverable value and contribute back to the economy. After intake and inspection are complete, the vehicle is moved into the processing area. The first step is removing the battery, the most dangerous electrical risk still present. In conventional gasoline cars, the lead-acid battery is removed immediately. This type reaches an almost perfect recycling rate of over 98%, since the lead, plastic, and even the sulfuric acid inside can all be recovered to make new batteries. For hybrids or electric vehicles, the much larger lithium-ion packs require an even stricter procedure. They are carefully detached, safely packaged, and sent to specialized recycling facilities. Only when the electrical system has been fully removed is the vehicle cleared to move on to the next stages of dismantling. After the battery is removed, the car is lifted onto a platform to begin fluid extraction, covering gasoline, engine oil, transmission fluid, brake fluid, coolant, and even refrigerant gas from the air conditioning system. Hydraulic clamps secure the frame in place, while a specialized steel probe pierces the tank and connects to a high-pressure vacuum pump. On average, an end-of-life vehicle still contains several gallons of fuel and fluids, enough to cause fires, explosions, or pollution if not handled correctly. Within minutes, everything is drained and directed into underground reservoirs. What makes this step notable is that nothing goes to waste. Once filtered, most of the recovered fluids are reused to power forklifts, generators, and other equipment inside the plant. The remainder is stored for in-house operations, helping to significantly cut energy costs. Throughout the process, pressure sensors, one-way valves, and sealing caps maintain a completely closed system, preventing vapors from escaping and ensuring safety for the entire line. Once all the fluids have been drained, the car moves into the stage of dismantling its major components. Wheels are usually removed first, since they take up significant space and are easy to process. Old tires are among the most difficult types of waste to break down, taking decades to decompose if sent to landfills. Instead, most are shredded into rubber granules for asphalt roads and playground surfaces, while others are used as alternative fuel in industrial furnaces. The steel and aluminum rims are separated and sent directly to smelters for metal recycling. Next come the windshields and window glass, cut out with specialized equipment. These are laminated glass reinforced with a PVB layer that prevents shattering. Recycling recovers not only the glass but also the PVB, which is reused in soundproofing materials and industrial coatings. Then the doors are removed, a seemingly simple part that actually combines multiple materials. The steel or aluminum frames are cut away for remelting, while the electric motors for window controls, locking systems, and wiring inside are stripped separately to recover copper, plastics, and magnets. The interior follows with seats, dashboards, and carpets carefully dismantled and sorted. Wiring is often stripped to retrieve copper, while plastics and fabrics are shredded and repurposed into new materials. Finally, the engine and transmission, the heaviest and most valuable mechanical assemblies, are removed. Some are refurbished for resale, while others are broken down further to extract aluminum, steel, copper, and even precious metals from catalytic converters. This systematic sequence of dismantling maximizes the remaining value of each component, while also ensuring that the next step, crushing the vehicle's frame, can proceed safely and efficiently. Before a car enters the crusher, it still carries a mix of non-metallic parts that are difficult to process, from bent exhaust pipes and large plastic panels to tangled wiring. To remove them, the vehicle is sent to the rough processing area, where massive mechanical arms fitted with hydraulic shears take over the job. With tens of tons of clamping force, the steel jaws rip off any remaining doors, yank out exhaust systems, or crush radiators in seconds. Plastics, foam padding, and other materials that cannot be smelted are discarded on the spot. Thanks to sheer mechanical power, the car's frame is quickly stripped clean of unwanted parts, far faster than manual disassembly. This cleaning step acts as a coarse filter for the entire line, eliminating materials that could ignite, contaminate the recovered metal, or damage the crusher itself. After only a few minutes under the hydraulic shear, the vehicle's structure is reduced to a neat steel and aluminum shell, ready for compaction with maximum efficiency and safety. Once the vehicle has been stripped clean, its bare steel frame is sent into a massive hydraulic press. Under crushing forces of 150 to 200 tons, a structure more than 4 meters long is compressed into a compact block of metal, its volume reduced to just a tenth of the original. Depending on the technology, this process can be carried out on different types of machines, each designed with a specific purpose. With a car baler, the frame is compressed into a dense, cube-shaped steel bale. These high-density blocks are easy to stack, store, and transport. Modern industrial balers can handle 25 to 40 cars per hour, making them ideal for large-scale facilities that need efficient storage before shredding. The car flattener, on the other hand, is popular in mid-sized or smaller scrapyards. It compresses vehicles into flat sheets only a few dozen centimeters thick. Its advantages are speed, lower energy use, and lower investment costs. The trade-off is that flattened cars are less dense than bales, meaning the later shredding stage consumes more energy. Meanwhile, the shear baler both compresses and slices, cutting the vehicle into short, manageable sections. Although its throughput is lower, it offers a direct path to shredders, or in some cases, directly into smelters, skipping the baling step altogether. If we compare them, baling is like packing goods tightly for storage, flattening is like rolling them thin for easy transport, and shearing is like chopping them into ready-made pieces for remelting. Different methods, but all share the same goal: transforming a bulky car into uniform metal, ready for its next life. Once the car's frame has been compacted, the dense steel bales are fed into a high-capacity shredder, the mechanical heart of the entire line. Inside its chamber, massive steel shafts with interlocking teeth rotate in opposite directions, tearing the compressed block apart within seconds. And in an instant, a car that once occupied a full parking space is reduced to uniform fragments of scrap. The throughput is staggering. A modern industrial shredder can process 100 to 150 tons of steel per hour, hundreds of vehicles each day. This sheer efficiency allows the auto recycling industry to operate at scale, transforming mountains of scrap into raw material ready for smelting. After shredding, the mix of metals and non-metals is carried along a sorting line. Powerful magnets pull out carbon steel first, while eddy currents deflect aluminum and copper to the side. Plastics, rubber, fabric residues are discarded. The recovered steel is compressed into bundles for the furnace, while aluminum and copper are collected separately for other industries. From a single discarded car, the line takes less than an hour to recover pure, reusable metals, ready to re-enter the cycle of production. What was once an old car frame has now been compacted, shredded, sorted, and bundled into standard steel bales. The recycling journey enters a new stage as these blocks are fed into an electric arc furnace. Here they face an inferno of heat. Graphite electrodes unleash currents of tens of thousands of amps, producing a blazing arc like artificial lightning. Within minutes, temperatures soar beyond 1,600 degrees Celsius, turning the scrap steel red hot before melting it into a stream of liquid metal. Lime and flux are added to draw out impurities, forming a layer of slag on the surface, while oxygen lances burn away unwanted elements. Sensors and spectrographic analysis provide continuous monitoring, ensuring the alloy composition meets exact specifications. From a chaotic mass of old car parts, a glowing sea of pure molten steel now emerges, ready to be cast into new billets. The molten steel, once refined, cannot be left to cool inside the furnace for long. It is immediately channeled through sealed troughs into the continuous casting line. A blazing stream of liquid metal flows into water-cooled molds, solidifying within seconds to form a hardened shell. Inside, the steel core remains molten, carried forward by rollers, and gradually cooled along the length of the line. From this process, long billets stretching tens of meters take shape. Square billets for construction steel, and flat slabs destined for rolling into sheets or coils. Automated thermal saws cut them into standard segments, each weighing several tons. Every billet is numbered, scanned, and logged into batches. From a formless pool of molten steel, defined blocks of material now emerge, marking the beginning of a new chapter in the recycling cycle. The moment they leave the reheating furnace, glowing red steel billets surge into the hot rolling mill, where dozens of massive rollers continuously press, stretch, and bend them into new shapes. With every pass, the steel flattens and lengthens, evolving from a heavy, rough block into uniform sheets or coils. High-speed cameras and laser sensors monitor each millisecond, measuring thickness and straightness with precision to ensure every strip meets the standard directly on the line. The process feels like sculpting muscle into metal, both powerful and precise. Freshly rolled steel cannot be sent out immediately. It must be cooled in a controlled manner. High-pressure spray nozzles envelop the surface in a white mist, rapidly lowering the temperature without causing cracks. Then, powerful fans blow along the length of the coils, allowing the steel to cool gradually and preserve its internal structure. Once the temperature is safe, each coil undergoes inspection. Ultrasonic sensors scan for hidden fractures. High-resolution cameras examine every surface detail, and mechanical testers measure tensile strength. Only those that pass are stamped and stored. From fiery brilliance to stable strength, steel emerges ready to serve hundreds of modern industries. From an old, seemingly useless car, the recycling journey unlocks an entirely new life cycle. It begins with dismantling every part, draining fuel for safety, then massive presses exerting hundreds of tons of force, followed by the thunderous roar of the shredder. The metals are then precisely sorted by magnets, eddy currents, and advanced sensors before entering the furnace to be reborn as new steel. Once hot-rolled, cooled, and inspected, the steel becomes a clean, durable material, ready to serve vital industries from construction and machinery to the making of new automobiles. Each end-of-life vehicle, instead of being discarded, fuels a multi-billion-dollar industry, cutting energy consumption and easing the strain on natural resources. It proves that recycling is not only an environmental solution, but also a hidden pillar of the modern economy. Have you ever thought that the car you drive today might one day become the steel for a building, a bridge, or even another car?